All right, got another one for you. What type of underpants do clouds wear? Thunderpants. Uh, okay. Like underpants, but thunderpants. Anyways. So today we're talking about a particular equation that we're going to use a lot, y equals mx plus c. You're going to hear me say this very often. You're going to hear me say it a lot. Um, And essentially what this equation is it defines a line, all right, a linear relationship. Okay, we're putting it into a form now so we can start to catch some patterns. Now, it's also known as the gradient intercept form, and I'll explain why that is, because there's two things we learn about it. Essentially, we learn about the gradient and the y-intercept. So each of these letters kind of means something. Now, what I'll say here is y and x. I'll write this down. Y and x, these are standard. Okay, which means in every equation, there will be a y and an x. Okay. Now, what is, I guess, slightly more meaningful is these ones here, m and c. These ones have a bit more meaning. Okay. Whereas every equation should have a y and an x, so your linear relationship. But m is going to represent the gradient of the line, and then your c is going to represent the y-intercept. Sometimes we call it a constant. But yeah, essentially m and c are your important ones in this equation. Okay. Now, a lot of the times they'll ask you to graph a straight line. And the way that we're going to do this is by one or two methods. Method number one, we've done from the first lesson. We're going to do a table of values. The second method is just using the gradient and the y-intercept, which is, you'll kind of see what I mean. So this first one here, let's just go straight to it. Graph the following lines. And for these two, what I'm going to do is I'm going to use a table of values first. So let's take a look at our table of values. I've picked some random values because it's the variable that I kind of change. And then for your y's, it's going to be whatever x is plus 1. So this will be -1, 0, 1, 2, 3. And then so I can just plot the points. -1, -2, -1, 0. Oops. Yeah, when x equals, sorry, let's try that again. So it says here when x equals to -2, y equals to -1. That looks more like it. And when x equals to -1, my dog, y equals to 0. When x equals to 0, equals to 1. When it's 1, it equals to 2. When it's 2, equals to 3. And you can see here that that becomes my straight line. Okay. Now, what I want you to note here is this is supposed to be the same as y equals mx plus c. So very, very quickly, you can see that the c, I should probably use a highlighter. And let's use yellow. You can see that the c is supposed to be the representative of 1. But you can also see here that my gradient, and I'm going to be nice, that's my dog. Now you can see here that there's only a singular x. And I should probably not make it so thick because that's impossible to read. But if I go with this, you can see that my mx, does it make sense that for this particular case, my m is just 1 because there's a singular x. There's no 2x, there's no 7x, it's just 1x. Okay, and I'm going to dot in that 1 because it's kind of invisible. Okay, and I'm going to do this because some people get confused with my 1s. Okay, so we can see here that m equals to 1. And so the way I could do that here is I can recognize, okay, well, my y-intercept is 1. And then my gradient is also 1, which means for every 1 that I go up, I need to go across, 1 across. Let's try this one here. Y equals -2x minus 2. Again, you can do this by a table of values. So you take whatever the x value is, you times it by -2. That gives us +4. +4 minus 2 is 2. Okay, and you do the same thing here. -2 times -1 is 2. Take away 2 is 0. And then I'm going to keep going. And at this point, you can kind of see the pattern. We're just minusing 2 every time. The reason that we're minusing 2 every time is it's part of our pattern. Okay. Same in over here. Can you see that my pattern here was I was plussing 1 every time? That's because the number in front of the x was 1. Okay, now at this point, x equals -2, y equals 2. There's my point. X equals to -1, it's 0. 0 and -2, 1 and -4. And you can see it kind of goes off the page a little bit. But that would be my straight line there. Okay, and again, my gradient in this case, just trying to make a point here, it's y equals to mx plus c. You can see here that my c is actually -2, and my gradient is also -2. Okay. Now, for these ones, I'm not going to highlight because that highlighting didn't do too well, but I'm going to show you that that's how I'm finding these answers. Okay. Now, for these ones here, now this is where your table of values is still doable and it will still get you there, but sometimes it's a little bit quicker to actually do this. Now, what I want you to note here is, can you see that the gradient is 2 on 3 and the y-intercept is -2? And so what I'm going to do here is remember that my gradient means rise over run, and a particular gradient for this one is 2 on 3. So I'm going to start with the point that I'm given, which is c equals to -2. You can label that if you want. And then what this means now is you may need to watch this video a couple more times to really get the hang of it. But what I want you to do is there's a rise and there's a run. Every time I rise 2, I'm going to run across 3. And I can see that there would be my next point. And so every time I rise 2, I'm going to run across 3. And so that there would be my fast way to sketch or to graph a line like this. So I can see here that that's 3, 0, 4, 5, 6. I can see that that's 6, 2. And that would there kind of complete my, what do you call it? So that would complete my straight line graph. Now this one here, let's continue the same thing. Let's take a look. My gradient now is 1 on 4 and my y-intercept is 3. So this time I'm going to do the same thing, start at 3. And it says for every, again, my gradient is always given by rise over run. And in this particular case, it's 1 over 4. So that means for every 1 that I rise, I'm going to run across 4. 1, 2, 3, 4. Now, to make my graph a little bit nicer, I can also kind of follow it. So that means if I go down 1, I need to go to the left 4. And you can see now that this line here is what my line should be and should go through the 3 points. That there would be the equation of that, or the graph of that line. Okay, last one, very last but not least, finding the equation of a line from a graph. So this time I've given you the graph, we're just working backwards. Okay, as usual, what I want to do is I want to be able to find, okay, can I find my rise and my run? And yes, I can. I can see that my run equals to 3. Now you got to be careful. My run is not -3 because I'm moving from the left to the right. Okay, my rise is still +2 because I'm going up. But in this particular case, with my right angled triangle, I can see that I'm running across 3, going up 2. So for this particular one, I can see that my gradient is actually 2 on 3. Okay, remember, I'm not picking the value, I'm actually picking the spaces, okay, the distance, the actual distance. And here, the last thing I need to know is what's my y-intercept? So where does it cross my y-axis? It's at the point where it equals to 2. So to write the equation of this line, it's just y equals m, which is 2 on 3. And then there's the x plus c, which in this case is 2. That would be the equation of the line. Okay. Now that was a lot of information. If you need to watch it again, slow it down, pause it, try it again. Hope this helps, and I'll catch you in the next one. All right. Bye.